Okay, so yesterday we saw about the DB replication. Okay, so yesterday, as I told you that we have configured DB replication. That is the replication of data from one system or from the primary database to the secondary database. Okay, that was about the configuration yesterday. But in any case, the switch over or the failover from the primary to the secondary will not be automatic. HSR HANA system replication only deals with replicating the change data from the primary database to the secondary database. It doesn't deals with automatic failover. In case if the primary database goes down, then you have to yourself. Yeah, sorry, just a minute. Yeah, so yeah, sorry for the disturbance. Okay, so where were we? what I was explaining. Okay. Okay, so high availability cluster. So yesterday we saw that we have configured the HSR, but HSR doesn't provide you automatic failover. So in case if you want to, and also you have to monitor the system for continuous monitoring, whether there is any kind of disruption in the service or whether the primary is up or not. So cluster, HA cluster, high availability cluster is a service or it's a program or it's an application which does this for you. It continuously monitors the service or the resources, okay, whether it's a disk resource file system, whether it's a service, anything else, anything, it will monitor this service from time to time, and then if in case of anything goes down, it will do the automatic failover. Okay, so now the cluster components. What are the important components of a cluster? So normally, just a basic understanding, I told you it's a software which does the monitoring and automatic, moving the resources from one node to another node. Now, there are some important components which are involved in a cluster, which helps it to identify whether the service is up or not, and in case of it is not up, then how to move it from one system to another system. Okay, so the first point here is your virtual and floating IP. So, okay, just in this screen, just understand the components and the terms, technical terms. What are they? How are they? How they come into picture? We will see in the next screen. Okay, the first is your virtual or your floating IP. Second is SBD. Okay, what does the SBD means? Stone it. Stone it is a acronym for shoot the other node in the head. Shoot the other node in the head. S T O N I T H. So this is it. To shoot the other node in the head. So Stoneit based device. SBD means Stoneit based device. Okay, what is that? That also will understand. And the third part comes here, load balancer. So these are the three new technical terms that you need to understand to understand how a cluster works for monitoring and managing the resources in a cluster. Okay. Is everyone clear till now? Any doubts and queries on this slide?
What is the SBD, Muzaffar?
Yes, I told you that we'll see it in the next screen. That what is the SBD and what it functions and what it does. Okay, so you just understand the technical terms here. It is virtual IP means it is not a physical IP. It is not assigned to any NIC. NIC means network interface card or an Ethernet adapter. It is a virtual IP. It means it is loosely based. As the name suggests, floating. Floating means sometimes it will be on one node, and if you want, you can remove it from that node and put it into some other node. You can move it to another node. Now, how it works, we'll see it in the explain. Same goes with the Stoneit also. SBD Stoneit shoot the other node in the head-based device, and the third is the load balancer. Okay, so now let me take you to the next screen to understand these all technical terms and this component. So very simple understanding. Yesterday, we had two systems, HDBPRD1 and HDBPRD2. So let's assume that these are the two systems which we configured yesterday, which were okay. These are the NIC cards on each of the nodes. 10.0.1.5, 10.0.1.6. Okay, yesterday the NICs, the system that we had, they were 10.5.1.5 and 10.5.1.6. So this is your normal setup over here. There is one node HDBPRD1 and another node HDBPRD2. Okay, this is the IP address for both of these nodes, and both of the nodes are HANA system replication is configured on both the nodes. It means your database replication is configured and in action in both the nodes. This diagram up till now, is it clear to all of you?
Yes.
Okay. So this is the example of our yesterday's setup. Two nodes, HDB PRD1, HDB PRD2, and we have configured HANA system replication on both of these nodes. Okay, just for one more before we start, right? Yesterday we had done the configuration, but right now we have I restarted the system, so it must have been gone down. Let me bring up the HANA database and check the replication. Okay, so we were here till now. So yesterday I paused the replication before shutting down. So right now we'll have to start the replication. Before starting the replication, I have to start the database on both the nodes. SU minus H4P HDB start. Okay, before that, let me check what is the system replication status on this node and also on the other node SU minus H4P. Should it take this much time? Okay, so this one is false. The database is not up and there is no replication, like it is not registered to any primary node or the registration is not enabled on this node. Okay, here this is your online is false. Again, the database is not running and the operation is primary. So this is okay. This is the primary node and the database is not up. So let me first start the database HGB start. After the database start, then we will register this node. We will register the second node with the first node to resume the replication. So let me start the database from the second node only. No, we need to start it after the. Okay, the database is started. Let me check if the database is started as SR state. Okay, so here you can see that the database is now online. This is the primary node and the site name Mumbai, site ID 1. Okay, and this is the source system true. And next, let me keep this command in under monitoring. So here you can see there are no secondary sites attached. Okay, because in the secondary, it is not attached. There is no replication mode configured on the secondary node. So to configure the replication node, I need to register the secondary with the primary. So here I am registering the secondary with the primary. Once I register the secondary with the primary, you can see it is now the secondary is connected, but still it is showing as connection timeout. So yesterday I told you why it is showing connection timeout, because the secondary database is not accessible. Why it is not accessible? Because it is not up. If you see the SR state, it will show you that the database is still online is false. So you start the database. Start the database. So
So I'm bringing the configuration to our yesterday's state of after we configure the replication. The database started, and you can see over here after some time. See, can you see? It has started. Yes, replication. It is starting a replication, full replica. It has started for the second. I think the second is completed for this access engine. So first one is also almost complete, and now it is doing a replication for the index server. Normally, in your real life environment, it won't happen so fast. Okay, this is because we have selected a plain vanilla database. We just did the installation and configured the replication. There is no data inside the database, and that is why it is happening so fast. Okay, in your cases it will take time. It depends on the size of the database and the speed of the network speed between your primary and your secondary. Okay, for example, it's like a 500 GB database, and it's on a cloud environment where the speed is fast. It might take up to like 20-30 minutes, half an hour, depending on your bandwidth and everything. So here it is. Now you can see the database is in sync with the primary is in sync with the secondary is in sync with the primary now. Okay, everything is working. It is in sync. It is in active all the state, and everything is okay. So now let us resume our the state. Let us resume a slide over here. So this is our current setup. We have two nodes, HDB-PRD1, HDB-PRD2, and we have configured HANA system replication HSR on both these nodes. The IP address of this node of one is 10.0.1.5, and here it is 10.0.1.6. Now this IP address are connected to a switch. Okay, just for your example, normally in our current environment, you might be having a virtual environment. For example, these two VMs are a virtual machine. They might not be physically connected to a switch or a router or something like that. But just to give an explanation, understanding, we have what I'm showing you is that these two are the NIC card. Okay, and both of them, the NICs are connected to your switch, your central switch over here. Now, on this switch only, there are application servers connected to the same network switch. Okay, for example, this is your S4 HANA PRD1, the S4 HANA PRD2, S4 HANA PRD3, and S4 HANA PRD4. These are your 4 application servers. So your database is also on the same network switch, and your application servers are also on the same network switch. Now what happens? You have a virtual IP 10.0.1.11. Okay, this is not a fixed, or this is not a static IP. This is not a physical IP. It means it is not assigned to any physical network card. Because when an IP is assigned to a physical network card, it is bounded, it is binded with that network card, and it is not easy to remove that IP from the network card and move it to another network, because when you remove the IP from the network card, the network will go down. So it is not easy to do that. So, but this is a virtual IP. What is virtual IP means? It is assigned on top of your physical IP or your static IP. Even if you remove this IP from your existing NIC card, it won't hamper your existing network setup. So the given in red over here, this is your virtual IP 10.0.1.11. In our case, we have set up the virtual IP as 10.5.1.11. So here in the information sheet, if you see over here, our virtual IP, this is the virtual IP host name. So our virtual host name is HDB-PRD1, and the virtual IP address is 10.5.1.11. And also when we did the configuration of the operating system, we entered this virtual IP in our etc host file. Okay, if you remember on both the notes yesterday, we entered tail minus 5/etc. Okay, so yesterday, you remember, we entered the virtual host name and the virtual IP address in our etc file. So here it is. Also, you remember that yesterday when we tried to ping this host name, the host name was getting resolved. For example, if I do a ping for my virtual host name HDB-PRD, see, it is getting resolved. I can see the resolved IP address over, but it is not pinging. The reason it is not pinging because it is not up. When will it come up? When we configure the cluster, then the cluster will bring up this virtual IP on your working node, the node, not your working node, on your primary database, the node which hosts your primary database. Okay, so this is the virtual IP 10.0.1.11. Now what happens when you do the installation? When you do the installation on your application servers, when you install the application server, there will be a stage. Okay, when you run the SWPM, software provisioning manager, at a stage there will come a screen where it will ask you to enter the details of the database server. Where is your database hosted? Okay, when it will ask you, there will be a screen where it will ask you for your DB host. When that screen comes, or in that field where it is asking for the DB host, you don't have to provide any of the physical or the static host name or IP address. You should not provide the HTTP PRD1 or the 10.0.1.5. Because what happens in case if there is a failover, if the primary goes, if there's a takeover, we will not use the term failover, but let us use the term takeover. So, for example, if the second node takeovers as a primary database, then if you mention your DB host as HTTP PRD1, then all this application server will lose contact with your backend, or will lose contact with your database, because this application server will go on searching for HTTP PRD1. But HTTP PRD1 no longer hosts your database because it has been taken over by the secondary system. So that is the reason when you do the installation in the DB host, you have to provide the HTTP PRD host name. That is the virtual host name. Okay, and when you provide the virtual host name, before doing that, you also have to make an entry in the etc host file for your virtual host name and the virtual IP address. Okay, for your virtual hostname and virtual IP. It means that before running SWPM, you have to make an entry same as this entry. The same entry that we have marked over here, you have to pass this entry in your all the application servers. No need for passing the entry to this physical IP and physical hostname. If you want, you can make the entry, but it is not mandatory. But this one is mandatory. You have to pass the entry for your virtual hostname and virtual IP address. So you have to make this entry in your etc host file on all the application servers, and beforehand try to resolve and ping or make sure that this virtual host name and virtual IP address is accessible from all the application servers. So then when you do the installation, at the time when it asks for the DB host, you will provide this name, HTTP PRD. Internally, it will resolve the HTTP PRD to this IP address, the virtual IP address 10.0.1. And what happens when the application server goes looking for this IP, the switch, your network switch will redirect the packets, or it will redirect your application server to the node which is hosting the virtual IP address. Is it clear with everyone? Any doubts and queries till now? Any confusion?
Muzaffar, where we actually put that virtual IP on switch itself or somewhere else?
No, not on the switch. It has to be on the nodes. See, here I'm just giving you the concept, the understanding. How it is done, we'll see in the practical side.
Okay.
Okay, and to answer your question, no, it is not. It is not configured on the switch. It is configured on the nodes itself. It is configured on the nodes itself, but there is a little you can say it's a little complexity, or you can say there's a little technical difference over here. Normally in your on-premise environment, if you are having an on-premise environment, for example, in your own data center, in your own physical data center, if you are doing the configuration, if you are setting up this landscape architecture, so you might have a physical machines, or you might have a VMware, you might have a VMs, virtual machine, which is hosted on maybe like a VMware, or maybe hypervisor, maybe this Hyper-V, Microsoft Hyper-V, or maybe VMware, this vSphere. In that case, this IP address will be hosted directly on your VMs. But in case of a cloud environment, there is a little bit different. You cannot directly assign a virtual IP directly on each of the Ethernet cards of your VM. There, in that case, the load balancer comes into play, which I will explain you in the next screen. So just to answer your question, this IP address are actually configured on the nodes itself. Okay.
Okay.
So here it is. I will show you practically how. I will show you on the system where it is and how it is like, and what at the time of moving, how it disappears from one node and how it appears in the other node. So now coming to this point over here. So I hope you have understood this diagram over here. How your application servers how they are redirected to the actual database or actual host, which actual system which is hosting your primary database. Now here in case if, for example, okay, now if example your HTTP-PRD1, that is your primary database host, goes down for any reason, the database goes down, the system goes down, there is a power failure, there is it's an planned activity or it's an unplanned activity for any reason, XYZ reason, the PRD1 node goes down. Now what happens in this case, the cluster, the cluster is monitoring your system. It is monitoring everything. It is monitoring your network IP address. It is monitoring the services of the database. It is monitoring the replication and everything. As soon as it finds that your database has gone down, what it will do? It will move the IP. Can you see over here? As soon as it finds out that your data, that the system is not up or it is facing some issues, having any kind of inconsistency, it will move the virtual IP address to the other node. And if you see over here, and the switch, once it moves to the other node, the switch will start redirecting the application servers to the other node where the virtual IP address is hosted. Is it clear?
Yes.
Okay, so this is how it is. The cluster manages your virtual IP address. So in this screen, we have understood that what actually is the, you can say, the functionality of a virtual IP address. Now coming back to the point to having your SBD disk. What is an SBD disk? Stoneit based disk, that is the shoot the other node in the head. Okay. Now, if you remember, yesterday I told you about a precaution. What is the precaution? That when you are running the takeover command on the secondary node, for example, if you want to make your secondary host as a primary, you want to run the takeover command on the secondary host and make it primary. The precaution that you have to make sure is that the primary node, the primary server, is down. You have to make sure that the primary database is down. Sorry, you have to make sure that the primary database is down. It should not be up, because if that primary database is up and you manage to take over on the secondary, and the secondary also becomes primary. When two nodes becomes primary, then there is a like most positive chances of data corruption. Because what happens, some data will flow to the node 1, some will flow to the node 2. The previous primary will also act as the node 1, and the secondary, which has now become the new primary, will also act as the node 1. Okay, so this will like create confusion and havoc in your environment. So that is the reason you have to make sure that the primary database is not up. So normally what happens in a normal environment, if the primary is working, there is no issue with the primary. If the primary database is if the primary node is healthy and you want to switch from the primary to the secondary, the cluster will the cluster will do the takeover. It will stop your HANA database, or it will do the stopping on the primary server. It will make the secondary node as primary, and it will do it without any issue. But sometimes what happens, for example, take a scenario, example in a case where the network switch, okay, or anything related to the network side of your primary node, it goes down. A very simple example, the driver of your network switch and then network card, NIC card on the primary, it hangs up, or the network hangs on the primary, or maybe someone unplugged the network cable from your primary system. If it's a physical system, somebody unplugged the network card from the primary database system, or might be that the the rack in which your primary database host, maybe not only your physical server, maybe the VMware vSphere server. Okay, the hypervisor server which is situated in your primary rack, which contains your primary database HANA host. Maybe the network of the whole rack has gone down. Now, when the whole rack has gone down, the cluster on the secondary system, the cluster on the secondary system is not able to communicate with the primary. Okay, see here what you said. See, everything will work. Everything will work properly when there is a proper communication. When the cluster will understand that the second node is working, when it is replying to its query. Okay, in case of any issue, the cluster will monitor the primary node. It will check. Okay, this has gone down. So the primary cluster will send an information to the secondary. Okay, my service, this service is going down. So the secondary will bring up that service on the secondary cluster will bring up the service on the secondary node. So when there is a proper communication, everything will work flawlessly. But in case if there is an like issue with your primary node, the primary node is not able to communicate about its current state with the secondary node. The cluster on the secondary node should understand whether it is up or not. How will it do that? Do you get this? So in that case, if the network goes down, then how will the secondary node find? How will the secondary node find that the first node is up or not, or whether should I take over or not? For example, the primary node is working properly. There is no issue with the node. Only there is a problem with the network. Okay, and if the secondary node it is not able to communicate with the primary, and if it starts takeover on the secondary node, and the secondary also become primary, there is a chance of what is called as a brain split condition. Okay, brain split means the brain has splitted. Both of the nodes have become primary. So this should not be the state. It is a very critical and it's a very like a state where there will be a chances of data corruption. So in this state, apart from having your network communication, what type of like foolproof solution they have brought is that in addition to a network communication, they have also added as a disk communication. Disk. So this disk, there will be normally you use disk in like in odd numbers. You can have one disk, you can have three disks, you can have five disks. But normally in a production environment, in a critical environment where the systems are critical, you normally use three disks. Okay, you don't use one disk, you use three disks for you to be used as an SBD, Stony based device. The three disk I use, but this is not a critical setup. And just to give you an example idea how it functions, I have only taken one disk. But everything will function normally. There will be no issues. But in your production environment, in your critical setup, use three disks. Don't use one disk. Okay, and don't use two disks also. See, this disk is used as a voting disk. It is also called as a voting disk. What voting disk? Both the nodes, the primary, the LGB PRD1 and the PRD2, both the nodes, they write their state, the health, their current, the health of them on this disk. And based on this disk, based on the values in this disk, the cluster decides whether the secondary node is up or not. Okay, now if there are two disks, okay, and one the cluster on the node one updates one disk. Okay, so now you have one yes and one no. So how can you have a majority? If you have a 50% data, then it cannot be a majority. It's a 50-50. So that is the reason you should have either one or three disks so that you can get full majority. In case of three, you will get it should be either two yes, one no, or two no and one yes. That is majority. So because of majority, it is recommended or it is mandatory to have odd number of disks, one or three. So this is the disk. It's also this is the shared disk. Okay, it's a shared disk. You create this disk and you map it to both the nodes. You map this disk to both the nodes. It's not a local disk. It has to be on a shared resource. So for example, if you are using a physical setup, then this disk should be on your shared storage, and this disk should be mapped to both the physical server or the virtual server, whichever they are. Okay, in our case, in a cloud environment, we'll be creating one disk and we'll be assigning it to both the nodes, the node PRT1 and PRT2. And it will be acting as the stone it. Stone it means shoot the other node in the head. So in any case where it finds that it is not able to determine the health of the secondary node, okay, and based on the condition, based on the health written on this disk, the secondary node will take the decision. Okay, I am taking over as the primary, and it will write to this disk. Once it writes to this disk, and if the first node is able to is able to communicate with this, what it will do, the cluster on the first node will panic the system. It will bring down the system. It will bring it hardly in a hard manner. It will not put the shutdown command power off. No, it will bring down. It will create a panic of the kernel. There will be a kernel, and the system will abruptly go down. That is why it is called as a shoot the other node in the head. Means don't wait to do anything. Directly kill it. I hope you get this point. Anyone? Any questions?
Refer that SBD is concept not clear.
So that is what I explained now, no? What
Okay.
was you not able to understand?
How this concept working like between both the
Same
nodes
thing
and
I
how
made you understand. That this is a one disk, which is a shared disk. It is mapped to both the nodes. And in case of the scenario where the first node is not able to communicate on the network and the second node is not able to communicate with the first node, in that case, they both will write their health information on the disk. This also acts as a voting disk. Okay, that is the reason they has to be used in odd numbers, 1, 3, 5. Okay, and in your production critical environment, you will have at least 3 disks. But here in our case, I'm using only one disk, and both of these nodes will write their health status on this node. And in a situation where the first node is not able to communicate with the second node will write the information on the disk, and based on this information, after it will take over the database of the it will take over and become the primary. And the second node, when it comes in contact with the disk, it will the cluster on the first node will panic the kernel of the first node. Yes, we get it.
so this SBD disk will kill the node. Something.
Yes, the information. See, the SBD disk will not kill it, because this is just a disk. It is just a storage device. The information which is written on this disk, the kernel, sorry, not the cluster will read the information on this disk. Okay, now it will read and write. It will read the status of the other nodes from this disk, and it will write its own status in this disk. And in case if the network is not communicable, if the network is down of your one of the system, then the systems will communicate through this disk. Okay, this is also called a disk-based heartbeat. Heartbeat is a link between both of these nodes. A cluster has a heartbeat to communicate between all the nodes of the cluster. So the primary heartbeat is a network-based heartbeat. Now this disk is also acts as a disk-based heartbeat. So in case the network of the primary server or the primary system goes down, it will write the information on the secondary. The secondary server write the information on the disk. The secondary server will read it, and it will write on the disk that I am okay, and now I am taking over as a primary, and you go down. It will write this information in the disk that I am taking over as a primary and you go down. The cluster on the primary will read this information, and it will create a panic of the system. The system will abruptly go down. Do you get it?
Yes, so we have other option also, I think, like pacemaker and other things which act.
Pacemaker is a cluster. Pacemaker is not another option. That is the actual cluster application and the cluster software which will do it. The pacemaker is the actual cluster which is monitoring the system, which is writing to this disk.
Okay.
Okay, so this SBD is a, you can say, it's a parallel concept. It is not included in your cluster package, you have two types of things are there for your clustering. That is CoroSync and Pacemaker. These are both two packages which combine to make your HA software, HA application. CoroSync is the application of package which provides the communication between all the nodes in a cluster, CoroSync. And Pacemaker is actually the package which is through that package you can create resources, you can create rules by how the cluster should act in case if one of the resource goes down and everything. So that is it. So this is your SBT disk and all. Okay, now comes your load balancer. In case if you are using a cloud environment, okay, your VMs are located in the cloud, then you cannot directly go and create a virtual IP address on your system. It is not supported in a cloud VM. In your local physical server, in your local in your VMware vSphere VM, or for example your Microsoft Hyper-V, there is a simple command. You can run that command and you can create a virtual IP. You can attach a virtual IP to your existing static IP. It's a simple command, and the same command you can use to detach that IP from the node, and you can run the same command on the other node to bring up the IP on that node. But in a cloud environment, actually the NIC card, the IP and the NIC card, even the virtual IP address, it is not so easy. It is not. It doesn't have the flexibility. You cannot directly attach IP address to existing NIC card, virtual IP to existing NIC card, and it will start working. It doesn't support in the cloud environment. So that is the reason in a cloud environment you have to create a load balancer, and you have to give that virtual IP on that load balancer. Okay, and then in the background you have to configure your cluster, and what happens, the cluster will assign the virtual IP to your system, and the load balancer will monitor on which node your virtual IP is up. So your application servers will be coming to this load balancer. The load balancer will guide the application servers to the correct system on which the virtual IP address is hosted. Is it clear? Okay, is it okay? So good. Let me move ahead. Okay, so I think these are the technical terms and which you have understood about the backgrounds of a cluster. How we can configure, what are the technical terms and the components of a cluster configuration. Now let us move ahead and start with the configuration of the cluster. It's a little lengthy and it's a little complicated process. It is not so easy and not easy to understand. In case if you have not worked before on HA, so this time it will feel little more complicated for you. But you have to come again. You have to go through this recording and this sheet a number of times to under clear understanding of what actually it is. Okay, so these are the prerequisites for a cluster, 2-node cluster, scale up single box to single box. Okay, you cannot set up a cluster on your scale. What is that other node? I forgot it. Scale up and scale
out.
Yes, scale out. So in a scale out, the cluster is not supported. It has to be a scale up environment, single box to single box, or a single VM to single VM. Stoneit method. The cluster must include a valid Stoneit method. So this is also one of the prerequisites. See, you can also Stoneit is actually a technology. It's actually a concept. It's actually a method. See, what we are using SBD, Stoneit based device. There are multiple solutions for this Stoneit method. You can use. See, there are in environment there are also UPS. Okay, UPS or power devices which support Stoneit method. What happens? Both of the node will be connected to your power device, and the power device will be acting as a Stoneit medium. So the device will be having information about both the nodes, which node is up and which node is down.
Okay, so in case if one of the node goes down, the other node will be able to get the status of the health of the first node from your the Stoneit device. It can be, I told you, it can be anything. It can be even a power device also. So this is, so you can have, what we are using is an HBD Stoneit based device, Stoneit based disk device. So we are using a HBD disk. So this indeed we are using the disk to help us to like determine the health of the other node. There are other solutions also available for Stoneit. So based on your requirement, you can use those also. DHCP assigned IP address, use one DHCP assigned IP address on one. Actually, this is applicable to your physical or your on-premise environment. Okay, that is the reason I have marked it as not applicable. Users and groups. Technical users and groups such as SIT, ADM are defined locally in the Linux system. They should not be in any kind of like central, there should be no central user administration. All the users, the SID ADM users should be created locally on all the nodes itself. Okay, here we have HDB PRD1 and PRD2. So the user should be created in both the systems in itself. They should not be in any kind of central system where the users are created. Name resolution of the cluster nodes and the virtual IP address must be done locally in the etc host file on all the cluster nodes. Even if you have a DNS system, DNS server in your environment, make sure to make the entry of this the DNS entries in the local etc host files also. Because in any case, if the DNS server goes down and the system is not able to resolve the IP address, it will give an issue. Okay, and within that small time of like within a small window of the DNS server going down, there could be a panic situation in the cluster because it will not be able to find the other node or not be able to find the backend system. So even if you have a DNS system, if you have multiple DNS servers also, anything, just make it a point to make an entries of all those nodes of your cluster in the local etc files of on all of the cluster nodes. Time synchronization between the cluster node using NTP. Okay, as you see, if you remember, while we are configuring the operating system or OS over here, we have a section where we configure the NTP service. But in our case, we have not configured the NTP service because I told you that in case of a cloud VM, there is no need for configuring NTP because the time synchronization is taken care by the cloud provider. So it is not required or not mandatory in a cloud environment. But in case if you're doing it in your on-premise server, then make sure to configure NTP on your systems. Okay, is it clear till now?
Yes.
Okay. So now coming SAP SID and instance number. Both SAP HANA instances have the same SAP ID and instance number. The SID and the instance number should be same. Again, this is the prerequisite from your HSR HANA system application. Cluster nodes placement. Okay, if the cluster nodes are installed in different data centers or data center areas, the environment must match the requirement of the SLE HAE cluster product of particular concern is the network latency and recommended maximum distance between the nodes. Okay, this is something which you need to take care when you are doing a configuring cluster in your data center or physical environment, physical or you can say on-premise environment. Normally in a cloud environment, this is not a prerequisite because the cloud environment, the latency between the nodes is very good and very high. So there is nothing that we should worry about the network latency in case of a cloud setup. So that's why I marked it as not applicable. Automated registration of a failed primary after takeover. So normally what happens when you first time configure the cluster, normally it is advisable or suggested to not have this setting. This is the setting. Automated register is false. So this is the setting over here. This is a configuration parameter. So the first time when you configure a cluster, just make sure to make it as false.
Because what happens, see, first time when you configure the cluster, it might not be stable. The cluster configuration might not be stable. What happens in automated registration when the second node takes over? When the second node wants to take over, okay, it will shut down the first node that will take over. Now when the first node comes up, for example, the first node was facing some hardware related issue, some any kind of like application issue, it was not coming up. So the second node will the second node will take over and it will become primary and will come up. Now after some time, maybe after a few minutes, maybe after a couple of hours, maybe 1 or 2 days, when the first node comes up, should the cluster bring up the should the cluster make register the second node with the primary node? Okay, it is not bringing up, it is registration. Now if the failed node, if the failed node comes after, if the failed node comes up after some time, should it be automatically registered to the primary or not? So this is the actual parameter. So as I told you, for starting configuration, it is recommended to switch off automated registration. Okay, you need, and after when you say when you find that your configuration has now become stable, now there are no more failover, automatic transfers, and there are no more surprises, then you can change the setting from automated register is equal to false to true. What is it actually? We will see it when we do the practical. Okay, then HANA instance startup at boot. Automated start of HANA instance during system boot must be switched on. Now there is a configuration in your HANA database when you're doing the installation. By default, it is disabled. It means if you enable this configuration, if you switch, if you restart your VM, if you restart the HANA VM, or if you shut down the HANA VM, and the next time when the HANA VM boots up, when it is started, the HANA database will automatically be started. It will automatically come up. Okay, this is the configuration. By default, it is disabled. So here the prerequisite is that don't enable it. Leave it as disabled only. Don't make the database to start up at boot time. AWS account, this is related to AWS account. All the component of the cluster in AWS should reside the same AWS account. Okay, leave it. Okay, so is it clear? Can we move ahead with the configuration now?
Okay.
Okay, so now what we need to do, see, before I can start the configuration on the VM, before we can start configuring the VM, there are certain things which you need to do on the cloud level. Okay, what is it? First, I think lab setup HANA. Okay, so what you need to do from the cloud level is that you need to create a load balancer. Here it is. So here, additional steps for HA. You need to create a load balancer. These are the steps for creating the load balancer. Okay, and in the load balancer, see, these are the steps. What resource group you want to put the load balancer, the name of the load balancer, type, it's internal, not a public load balancer. It is an internal load balancer. Front end configuration, the name, and this is the IP address subnet. It will be a static. This is the virtual IP that we are putting on your load balancer 10.5.1.11. This is the IP. Then the backend pool. See on which node, on which VMs it should look. What are the backend VMs that will be associated with this load balancer? Okay, so in one of these VMs, this physical IP will be up, and the load balancer job is to redirect the traffic to that VM which hosts the virtual IP. Inbound rules. So there are some inbound rules over here, and there's this floating IP enabled everything. So this is how you can create a load balancer. So normally you can directly go into your you can open your portal. Okay, here you can go into your home. You can open the home and you can go into all services. You can go into all services, and then in the network, you can click on all services, and from the all services, you can go to the network, and from the network, networking. In the networking, you can select the load balancers. Can you see this is the option over here? So I've given you all the steps in case if you are doing it practically, if you want to create a load balancer, this is where you have to go. Networking load balancers create. Then these are the values of all the screen, all the values that it will ask you for. Okay, but now since I want to just save some time, I have all the scripts with me. I have all the commands with me. So instead of creating the load balancer from the portal, I will directly go and I will create the load balancer from the this one cloud shell. I will directly create the load balancer using commands from the shell. Okay, so this is the command to create a load balancer. This is the command to create a probe, and this is the command for load balancer rule. These are different configuration over here. And the second prerequisite is to create and attach an Azure shared disk to HANA nodes. So till now you will be creating the load balancer. After this, you'll create one disk. Okay, the disk can be minimum, it can be like 1 GB also. There is no restriction on the disk is not like a maximum size or high capacity disk. It can be of 1 GB also. But in a cloud, in a Azure cloud, you don't have a disk of the size 1 GB. The minimum disk that is available in Azure cloud is 4 GB. Okay, and that also it's a premium disk. So that is the reason we'll be selecting the 4 GB premium disk. We'll create one disk and we will attach it to both the nodes, the PRD1 and the PRD2. So these are the two steps, or these are the two configurations that you need to make from your cloud. Make from your cloud account. Okay, so my shell is up. I need to create a load balancer. If you want, you can check if there is an existing load balancer in your system. Okay, you can see there is no load balancer. If you see the output of this command, there is no load balancer. So now here I'm creating a load balancer. If you go over here, I showed you, like for example, the home. There is a shortcut over here for load balancer. I can directly go to the load balancer over here, and you can see the load balancer that it is being created. Can you see this load balancer is being created now? If I would have seen it before running this command, you would have not seen any entries on any load balancer over here. After running this command, it has created the load balancer. So now if you run this command to check the load balancer, so previously it didn't give any output, but now see it is giving this output. So my load balancer is successfully created. Now you can create a LB probe. In case if you check over here, if you click on your load balancer, I think there will be something over here for the health probe. Node embossing. Can you see the health probes? In your health probe, you cannot see any value or any entries over here because it has not been created yet. Now I'm running the command to create the health probe. Okay, here I'm running the command to create the health probe. After this command completes, when you come again to this screen and you refresh it, you will see a health probe value over here. See, can you see? It has come now. This is the health probe value which is being created by this command. It is not yet completely created, but it's still in progress. Okay, if you want to see the health probe, you can see the output over here. Okay, this is the health probe. Previously, it would have not written any output, but now after the health probe is created, it's returning this output. So your health probe is created over here. This is the health probe. Okay, you can see the port here also 62501. So if you see over here, there is the port. This is the port 62501 that we have assigned to this health probe. Okay, now we are creating the rule. The rule for this one. If you check the rule output now, it will be blank. Okay, there is no output for your rule. And again, if you come back and if you go to the load balancing rules, here again it will be blank. There is no rules for your load balancer now. So you can create the rule from here. I can create the rule to yes. So here I'm creating the rule. Now, if you click on refresh over here, you will see that a rule. See, can you see the rule has been created over here? This is the load balancing rule. Backend pool. It will be connecting to this backend pool, which contains both your backend systems into this pool. Okay, it is done now. Let me check the output for this. Okay, then let me run this command, which will assign both these nodes to the backend pool. If you check the backend pool now, it should be empty. Now here is your backend pool. So if you see the backend pool, you can see this is the backend pool which is assigned to it, but no nodes. See, can you see this area, the IP configuration? No nodes have been assigned to the backend pool now. Okay, if you see this part, no nodes have been assigned to the backend pool as of now. So now let me run those two commands, and after that you will see the nodes which will be assigned to this backend pool. So here, okay, here I'm running both this command, paste. So this is for the first rule. If you want, you can come over here. Let me again go back and again refresh this. Can you see over here? One node has been assigned to this backend pool. Okay, this is the node HDB PRD1. It is still running. Once the second command is also complete, you will see two entries over here. One for the PRD1 and the other for the PRD2. Okay, the first node has been assigned. Now it is assigning the second node. Now if I click on the refresh over here, you can see the entry for the second node. Can you see? Second entry for HDB PRD2. Okay, I think it has completed successfully. Now, before it was giving this one, let me check if there is any change in these outputs or not. Let's check the IP config one true and check IP dynamic succeeded. I think it's the same output. There is no change in the output. Okay. Okay, so the load balancer has been created successfully. I've created the load balancer. I've created the backend pool. I've added the VMs to the backend pool. I've created the health probe. I've created the load balancing rules. So these are the basic steps which are required to create the load balancer. The load balancer has been created. Now the next step is to create a virtual. Now it's just to create a disk of 4 GB. Okay, if you want to see all the disk in your existing account, you can run this command to check the disk. See, these are the different disks on your account. You can see the sizes over here. Can you see the 30 GB, 32 GB, 32 GB? These are the sizes. So almost most of them are 32 GB, and the OS disk are 30 GB. So now, if you hear, this is a command to add a disk of 4 GB, premium disk of 4 GB. Okay, so this is the disk of 4 GB I'm creating. Okay, so it has been created. Now, if I run again the command to disk for output disk, okay, can you see the last entry over here, which was not there before? This entry was not there before. The disk with a 4 GB size. If you see the previous entry, there was no disk with 4 GB. Now you can see there's a disk of 4 GB and it is a premium disk. Okay, it's a premium disk over here. This is the disk. Now, but if you go to the VMs over here, if you go to the VMs, this is the VM PRD1. If you go to PRD1 and you click on the disk, Okay, if you click on the disk, I can only see the 3 disks which were attached to it during the time of creation. Can you see only 3 disks? And all the disks are of 32 GB, 32 GB, 30 GB. Similarly, for your PRD2 also, I can see 3 data disk of 32 GB each. So we have created the 4 GB disk, but it is still not assigned to the both the VM. So here I have created the disk. Now let me attach the disk to the node 1, VM1. Let me attach this disk to VM1. So here I am attaching the 4 GB disk to the node 1. Is it clear till now? Okay, the disk has been assigned. Now, if you come over here, if I click on the node 1, can you see the only the 3 disks? Now, let me click on the refresh button. Now, once you click on the refresh button, you can see a 4th disk. Can you see a 4th disk of 4 GB premium SSD disk has been assigned to the node 1. This has been assigned to node 1. But if you go on to node 2, it is still not attached or assigned to the node 2. So for that, we need to run the second command, this one, to attach it to the second node. Here I'm running to attach it to the PRD2. This is the disk that will be used as an SBD device, the Stonit based disk. Okay, so it has been attached now, assigned now. If you go here, if you click on refresh, okay, can you see again? This it has now attached the same disk to both the nodes. I have attached the same disk to both the nodes, PRD1 also and PRD2 also. The same disk will be visible from both the nodes. Yes, everyone, are we clear on this till now? Yes, anyone? Okay, so now let me start with the configuration part. It's quite lengthy, so let us start quickly. Okay, so now first is you to disable TCP timestamps. Okay, if you see that this is the pointer clue over here. TCP timestamp will cause the health probes of your load balancer. Health probes to fail for Azure VM placed behind Azure load balancer, and this is the reason you have to disable TCP timestamps. How to disable them? If you see the default value on both the nodes, now when you're doing the configuration, you have to make sure that you do the configuration on both the nodes. And all this configuration that I'm doing now has to be done with the root user. So let me log out from here, from the SID IDM user, and let me log in with the root user to both the system. And if you see the configuration, the value, the current time is 1. It means it is enable. In Linux, in a Unix system, 1 means enable, 0 means disable. Okay, so here by default, if you see, it is enabled, 1 is enabled. So now if you want to disable it, you have to give the value of this timestamp into this file and make it 0. So let me run in both of the nodes. You have to run this command in both of the nodes. So both of the nodes, you can see that it is 1. So you have to run this command on both of the nodes. Okay, so you can see the default value has changed to 0. Again, here the value has changed to 0. Just ensure that you run the command on both the nodes. If you forget to run it any one of the nodes, it will give you issues in the future. It will be very hard to troubleshoot. Create and attach an Azure shared disk. So we already have created the disk and assigned or mapped it to both the VMs. Now you need to configure SBD. check if the shared disk is visible on both the nodes, LSBLK. If I run LSBLK here, you can see this is the disk SDF. It's of 4 GB disk. It's a 4 GB disk. Again, I running LSBLK on the second node. If you see, I can see the 4 GB disk on both the nodes. It should be visible on both the nodes. Now create the SBD device. This is the command to create the SBD device. Now you don't have to run this command on both the nodes. Why? Because it is a shared disk. Once you create the once you create the signature on one disk, it is not required to again create it on the same disk from the second node. So you only have to do it once from any of the nodes. Okay, so first time if you run the dump command, it will not return you anything. Okay, can you see SBD failed? It will not return you any value. SBD failed. Here again, if you run this command, it will show you SBD failed. So now you have to run this command. Okay, I'm running this command from any one of the nodes. See, it is saying initializing 255 flyers on device 3, and it is writing the header on the disk. Okay, now if you run the same command, if you run the same for the dump command, you can see the information on the disk. Here you can see the information on the disk. This is the information header on the disk. Again, when you see the from the second node, you will see the same information. There will be no change. Even everything. And you see the UUID, it's a unique ID. The UUID and on the disk also the CUSI ID, everything will be same because this is a common disk, shared disk. Done. You update the SBD configuration. So before now you have to add this disk in the file. This is the file which contains the disk over here. Now SCD minus a disk. If you see the file, if you see the content of this file, what is the part? etc sysconfig SBD. Less slash etc sysconfig SBD. If you see this file, here is the parameter over here, SBD device. So by default, it doesn't contain any value. Look at this device, the SBD device value doesn't contain any value. So we are going to change this and we are going to add this value. Can you see this value? We are going to add this value, the DSK, we are going to add this value to the file. Okay, this is the value that we need to add to the file. Okay, so if you want to make sure for this file, okay, first take a backup of the configuration file. Again, when you do this, you have to make sure you have done it on both the nodes. Take a backup of the configuration file on both the nodes. Okay, I've taken the backup. Now check the value. This value which is over here, this is for my last class. This is the value from the disk of my last class. So this is not the current value of the disk. So run the ls command, I get this value, copy this value and paste it over here. When you paste this value, this command will change. If you see, if I run the undo command, see the value is changing. The value is changing. So you have to take the latest value from your current system. Take the value, paste it over in the red box. So once you paste it, the next command will be updated. You can see the change in the next command. Okay, we'll do one thing. We'll take a break of 10 minutes and then we'll continue. Okay. Yes, is it okay with everyone?
Okay.
Okay, so last time what we did over here, okay, we have got the value for our current disk. Okay, right now if you see the value grep starting with hash sbd underscore device from this file. Okay, so right now this is the current value over here. So what I'm going to do, I'm changing the value inside this file. Okay, so it has changed. Now it has it will be uncommented. Now this value will be uncommented. Earlier it was commented starting with the hash. Now this value has changed to uncommented, and it contains this value which we have put, which I changed with the command. Again, let me check it with this. Do it on the second node also. Okay, so it is done on both the nodes. Difference, check the value difference. Okay, so earlier it was this value and now this is this value. Configure software watchdog. So configure software, if you check it beforehand, this is not there. Ls node software, it is not here. So we are going to configure it. Eco software. So now you can find the softdog process, or you can see the daemon in the memory now.
What does this soft dog?
Okay, this software is actually for monitoring your SBD disk. The storage based device disk. This is a software is actually for monitoring those. So let me show you some detail last one. Azure ability guides user base performance. Use an ability device. To let the software configuration details earlier. You can check for the software. The kernel is only method to enter a HANA system called watchdog. Watchdog is simply a control model that checks a timer to make sure the system is healthy. So you can see the details of over here. What is actually a watchdog? What it does? It monitors your disk over here, and there the watchdog is actually in hardware hardware monitoring, and we have a software watchdog over here. Enable watchdog in kernel. Softdog, kernel panic, or hang or reboot to force the system to boot instead of halt. If the kernel panics, modify the boot parameters passed to the kernel. Configure heartbeat to support watchdog. The watchdog code also supports a software replacement for external hardware timers called softdog. Here it is. So the watchdog is actually an hardware device, but here you can use the software timer, which is called as the softdog. Softdog maintains an internal timer that is updated as soon as another process on the system writes to the dev watchdog device. So this is a detail about. I think. Let me see if I have the. No, it is not given over there. So let me add it to the disk. The details of what is a software watchdog. Watchdog and Softdog. Okay, is it okay? Can you move ahead now? Yes.
Means it will check which system is in working state, node 1 or node 2.
Yes. 1 minute. The kernel has its own method to handle a hung situation called watchdog. So if the kernel gets hung, okay, how will it identify? It has its own method called as watchdog. Watchdog is simply a kernel module that checks a timer to make sure the system is healthy. If the watchdog thinks the kernel is hung, it can take drastic actions such as system reboot. So normally what happens if the kernel gets hanged up and if nobody is checking, see kernel is the main part of your Linux system, the operating system. It is actually your engine, it is actually your driver. So now who is monitoring the kernel? If the kernel goes in a hang state, now nothing will happen. The system will get hanged itself. There nothing will happen. Nothing will move ahead. Nothing will get pushed. So this is an external device. You can say external, a program called as Watchdog. It is monitoring your kernel. If the kernel goes in a hang state, it will actually reboot or shut down your system. You get it? If the watchdog thinks the kernel is hung, it can take drastic actions such as system reboot. If you want to protect your high availability server configuration from a server hang that causes an interruption in the services, even when the server is hang is not detected by the heartbeat, you should enable watchdog in your kernel. Do you get this?
Yes.
Okay, so if the kernel is not able to monitor itself, the kernel goes in a hang state. So how will you determine whether the system is healthy or not? So this is a watchdog. The name itself suggests as a watchdog. So it is watching your kernel. If anything happens to it, it will restart the node which is in a hang state. Okay.
Okay.
Okay, so configuring software watchdog. This is a good point. I configure a check instead of marking it and say, let me make it point number 3 because this is not related to your SBD. That's 3. Then comes your HA configuration. Then that's good. So here it is. We are done with it. Now we are done with the watchdog. Let us start with the configuring HA cluster. Okay, so first thing before the configuring cluster, you should update your OS packages. You should update your operating system, but we are not using we don't have a valid subscription. Okay, in case if your system has a valid subscription, you can run this command zipper update. But if you give this command here in our system, it will give an error that you don't have a valid subscription. Okay, if I give this command over here, you can see no repository is defined because we don't have a valid subscription. So if you have a license or you have a purchase a subscription, you can run this command. It will update all the packages on your operating system. Now, cloud net config manage. So here we are disabling the net config network. There is a tool for configuration of your network. Okay, so we are disabling the cloud networking net config manager because it interferes with your management of the network device. So just make it just disable it. So the before the configuration, you can check that it is and it is years. Okay, in both the system, if you check, it is years. So you have to make it no. You have to make it no. Okay, here I have make it no, and again on the second device, I'll made it to no. Okay. Then generate now set up passwordless SSH between the nodes. Now what happens if I SSH the other node? If I SSH node 2, if I SSH node 2, it is asking for a password. Okay, are you sure you want to connect to the node? Yes, it is asking for the password. Without giving the password, it will not allow me to log into the other node. The same goes here also. If I try to log into the other node, that is PRD1, it will not allow me to log in. It will ask for the password. So what is the required prerequisite for a configuring cluster? It should be passwordless SSH from all within all the nodes of the cluster. So before that, you need to create an RSA key.
Okay, you need to create an RSA key. So this is for RSA key, or you can just simply give the command SSH-keygen. Enter, 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 enter. 3 times enter. This is your RSA key over here. Okay, this is the RSA key over here. This is your key for this system. Again, give the same command over here. SSH-keygen. Okay, just give the command 1, 2, 3, enter, and this is your RSA key. So we have generated the key in your system right now. So if you check in your root user's home directory ls.ssh, so this directory is created, and you can see the public key over here, and you can see the private key. This is the private key, id_rsa. This is a private key, and this is a public key. If you check this id_rsa, this is your private key. You can see over there. Can you see this is your private key? And if you check for this one .ssh id_rsa.pub, this is your public key. This is a public key which you can share with other nodes. If you share this key with the other node, they will be able to log into your system without the password with the key of the user which you have shared. Okay, if you share the key of the root user, you cannot log in without password with a SID IDM user. So you have to share the key of the user which you want to make in a passwordless connection. So I've generated the key. Now you need to copy the key. See, I'm copying the public key. I'm copying the public key to the other node. This is the command to copy the public key to the other node. SSH-copy ID -I. So I'm copying it to the other node. From 1, I'm copying it to the node 2. Okay, from here, I'm copying it to the node 2. So can you see now? First time it will ask you for the password of the other node. The first time to verify whether it is you are authenticate or not. First time it will ask you the password. Give the password. Now can you see? Now try logging into machine with this command. Now if you try to log in to the other node with this command, see it will directly take you to the other node without asking for the password. So now you have enabled passwordless login from node 1 to node 2. Now you have to do the reverse. Now you have to do it again from node 2 to node 1. Now I'm copying the key from node 2 to node 1. It is done. Now I'm trying to log in from the node 2 to node 1. Can you see? I'm able to log in without password. So this is passwordless SSH. Okay, now coming your setting up cluster. So first you need to initialize cluster on node 1, and then you need to add the second node in the cluster. First you need to create a cluster on node 1, then you need to join the second node in the cluster. So first you have to run this command on node. You can see over here. See, this column is for node 1, this column is for node 1, node 2. So wherever it is asking you to run, you have to run on that node only itself. So here you can run on cluster node on the first node. You run this command on the first node. This is the second node. This is the first node. Run it on the first node. Cluster init. So here I'm creating. Now you can see the values over here. So y, enter, y. Okay, the first is y. Then again for the second, address for ring 0. See here it is asking the address for ring 0. Just enter. Again, port for ring 0, again just enter. Okay, do we wish to use SBD device? Do we wish to use SBD device? Yes, enter. SBD is already configured. Overwrite? No, don't overwrite, enter. Okay, now it is configuring the cluster. Logging with the username HA cluster, password is Linux. So this is a common user HA cluster for your pacemaker cluster, and this is the password for the HA cluster user. So this is a common password, which is a security breach. You need to change this password after configuring your cluster. See, it is saying giving you the warning. You should change the HA cluster password to something more secure. Okay, so after this, do we wish to configure virtual IP address? Do you wish to configure virtual IP address? No. Okay, last one, do you want to configure Q device? No, enter. So I've done. Now I'm done with the first one. Okay, I'm done with the setting up the cluster on the first node. This is done. Now I need to add the node 2 to cluster. so that I need to join the second node to the cluster. So you need to run this command on the second node. So I'm running this command on the second node, CRM cluster join. Now it will ask you the details, IP address or host name of the existing node, to which node you want to want this cluster to join. Okay, the node is this. So this is the node, enter, and this is the IP, enter, continue. The second continue, yes, enter. Then comes the address for ring 0, just enter. And address for ring 0, enter. Got SPD configuration. Again, it is telling you to change the cluster for the HA cluster user's password. Waiting for cluster, reloading cluster configuration, done. Okay, so your configuration part for the node 2 is also done. Okay, am I clear till now? Any issue, any doubt? Okay, so now set the password for HA cluster user. So here we are setting the password for the HA cluster user to India123 with capital I. So you have to change it on both the nodes. So here I'm changing for the node 1 and here I'm changing for the node 2. Okay, the password has been changed. Now, yes, this is done. Adjust corosync settings. So these are some settings we need to adjust. Okay, if you see over here, we're taking the backup of the corosync file. We have to done it on both the nodes. So I'm taking a backup of the corosync file. Here I'm making the changes. So there's a token which I'm changing from 5,000 to 30,000. Consensus from 6,000 to 36,000. Expected votes from 1 to 2. Here I'm making the changes, and here I am seeing whether it has been changed or not. So you can see over here. In the previous file, it is 5,000, backup file 5,000, and the current file it is 30,000. In the backup file, it is 6,000, and in the current file, it is 36,000. Okay, so now we need to do the same, run the same command on the node 2 also. Okay, is it clear? So we have run the command on both the nodes. Now restart the corosync service. So you need to restart the corosync service system, restart corosync, watch systemctl status corosync. So here I'm restarting on the node 1. Okay, here it is monitoring the service over here. See here you can see the last line, started corosync cluster engine. So the service has been started, it is restarted. Again run the same command on node 2. Okay, here you can also see started corosync cluster engine. So the service has been restarted. Check pacemaker service. How can you check the pacemaker service? Systemctl status pacemaker. Okay, so since we have not made any changes in the pacemaker, you don't need to restart the service. Just check whether it is running or not. So I'm running the command status. So you can see over here. Can you see the status transition idle, SMS idle? So this service is running. You can see it from here, active running. The pacemaker service is running. Then again, let me check on the second node. Here also you can see that the pacemaker service is running active. Okay. Now checking the cluster configuration. What is the configuration? This is just for your verifying whether the cluster is running or not. These two commands you can give it on both the nodes individually. So I'm giving it on both the nodes. Here you can see, and this also on the second node I can give this command. Okay, most of the output is the same. The only difference that you will find in both this command, here you will see the IP. Can you see the IP? It is 10.5.1.6. On the first node, it is 10.5.1.5. So here it is 1.5 and here it is 1.6. This is the only change here. Also, if you see in the second command, the corosync quorum tool, you can see that here on the second node, this is showing as the local IP. And on the first node, the first one, 1.5 is showing as the local IP.
Okay, rest of them, all the content, all the output of both the commands are same. So we have executed them on both the nodes. And these are the command, the output of this command on both the nodes will be same, 100% will be same. So no need for running it both the node. You can just run it on one of the node and you can see the content. So this is the, so this is for this, the Corosync CPG tool. This is the detail. Then you can see the configure. This is the configuration of your existing cluster. CRM configure show. This is the configuration of your existing cluster. This is the cluster status. So here in the cluster, you can see that you have, it is running, active running. The Corosync service is active running and the pacemaker service is active and running. The CRM status. So here, if you see the CRM status, you can see that the cluster is online and both the nodes are member of the cluster. Both the nodes are member of the cluster, and you can see the Stonith device over here. You can see the Stonith resource over here. So this is the resources of your cluster. So right now we only have one resource. The cluster is only monitoring the Stonith resource this right now. Okay, so your cluster, this is over here. So okay, in the last for the CRM status, there is one note over here. There should be two nodes with the status online. So if you see over here for the status online, there should be two nodes. Okay, both the nodes should be displayed over here, not any one of the nodes. If it's showing any one of the node, it means there is some problem, there is some issue. Both the nodes should be shown as online over here. First point. Second, the message partition with quorum. So also you have to see the message over here partition with quorum. This message should also appear. So these are the two things that you need to make sure that it is displayed in your CRM status before you can continue your cluster configuration. Okay, now you need to start the Hawk service. This service is for your cluster web console. You can access the cluster web console. You can access your cluster from a GUI, from a web browser also. You can access the cluster from a web browser, but just believe my words, it is not an advanced tool. The Hawk tool or the console tool is not an advanced tool for monitoring or managing your cluster. It sometimes, if you get stuck with the tool, it will gives a lot of problem. So just believe my words, I would not recommend you to use this browser tool, the Hawk, which is called as the Hawk tool, for managing your cluster. You can do the monitoring from the tool, but managing your cluster is not recommended. Okay, so by default it is not started. If you check the status of the tool, SYS system CTL status HAWK. So by default, okay, it's already running. So you can see over here the status is running, and you can also check for the other Hawk tool. It is already running. So can you see HA web console? This is your HA. This is your web console. What is it? So it's a web. Yeah, it's an HA web console. This is the correct name for it. HA web console is already running. So I don't think you need to. It's not applicable because it's already running. Okay, now check the Hawk. If you want to check the, you need to check it for each of the node. You can open a browser. Okay, so let me open for the node 1. This is the web console for node 1. This is the web console for node 1. It is giving a certificate error. Just click on advance and accept and continue the risk. Okay, it is asking you for the user for your login. So what user you are going to use? The HA cluster user. You are going to use the HA cluster user. The HA cluster user and the password India123. Okay, this is the user for logging into your web console. So you are going to use the HA cluster user and the password India123.
Okay, so there you can only see one resource over here. This is for your node 1. You can run the same for node 2 also. Same for your node 2, advanced, accept the risk and continue. HA, cluster. Save. Okay, so here I've got the status for both of your cluster. You can monitor it from here. Okay, this is done. Okay, now till here we are done with the cluster setup. We have set up the cluster. Okay, only the cluster we have set up. Now, before we can start, we need to implement a code. We need to implement a code for monitoring your replication. Okay, that code is written in the Python language. That code is written in the Python language, and it is called the program is called as SAP HANA SR. Okay, SAP HANA SR means system replication. SAP HANA system replication. This code is also called as a system replication hook. It attaches to your cluster and which gives the information about which monitors the replication and gives the output to your cluster. Okay, so the cluster relies on this SAP HANA SR program to get the information about your replication status of the HANA database. So now you have to log in with the HANA SID ATM user. You have to stop the database on both the nodes. Okay, I need to log in into with the SAP HANA this one. Log in with this user on both the nodes and stop the HANA database on both the nodes. So let me stop the HANA database on both the nodes. Okay, so after the database stop, okay, the database is getting so after database stop, we need to integrate this SAP HANA SR into your global.ini. That is the configuration file for your HANA database. You have to integrate. So what actually you have to do, you have to add this container. This is called as a container. You have to add these 3 containers in your global.ini file. The first container, HANA DR provider SAP HANA SR. So this is the provider name. This is the path for the SAP HANA SR code, the Python code. Execution order 1. This is the trace container, and what the trace level you want, it is set to information level. System replication communication enable SS on. So these are the 3 containers that you have to append at the end of your global.ini file. Okay, so HANA database is stopped on both the nodes. If I check HDB info, okay, so the database stopped on node 1. Again, if I check on HDB info on node 2, I can see that the database is stopped. Okay, so database is stopped now. I'm taking a backup of the configuration file, the global.ini file. Before making any changes, I'm taking a backup of the file. Take a backup on both the nodes. Okay, I'm taking a backup on both the nodes. If I see a differential between the backup and the current file, both are same now. There is no changes. Now I'm going to add these lines. I'm going to add these lines in my file, in my global.ini file. And I'm adding these 3 containers in the file over here. So now you can see I've added this with the year character. This is called as a cat. I appended these lines into my global.ini. Similarly, I'm doing it for the second node also. Okay, now when you run the difference command, you can see the difference between the backup file and the current file. See, and you are seeing the difference between the backup file. So in the current file, you can see these are the additional lines in your current file, which is not there in the backup file. So here I have added the replication hook on both the nodes. Okay, now configure sudo to allow SID admin to access the cluster attributes. So this again your command that you have to execute on both the nodes. For it, it will allow the cluster to execute the SR hook commands on both the nodes. Here, I think might have to do it with the root user. Okay, permission denied. So you have to do it with the root user. So that is it. This command needs to be executed with the root user. This is the root user again, come out and execute with the root user. Okay. Now again log in with the SID IDM user and start the database on both the nodes. Okay, is it clear till now? Any doubts, queries? Okay, so let the database start. Okay, so it has started on the secondary node. The primary database is still starting up. Once the database is started, you run this command grep HADR SAP HANA UR and check it in the trace file. If you find some output, it means the hook has been successfully integrated with your database. If I run this command on the secondary node, I don't think I will get any output. See, no such file or directory. It is not the, oh, sorry, this has to be PRD to be not one. Okay, I cannot see any output on the secondary node. But if I run the same command on the primary node, see, can you see? I can see this output over here. So it means the SR hook, the Python code has been successfully integrated with your HANA database. Now comes the configuration part. See, last time we just set up the cluster. In this part, before the HANA SAP HANA SR hook, we just configured, we just created a cluster and we joined the second node to the cluster. Now in the sixth phase over here, we are going to configure the cluster. That is, we are going to create resources. We are going to create resources in the cluster. Okay, so first you can run this command over here. Run this command on the second node over here. It has to be done. All the configuration has to be done with the root user. So login, just come out of it on the SID IDM user and run this CRM underscore mon minus R command on the second node. It will continuously monitor your cluster. This command will be continuously monitoring your cluster. So I have run this command on the second node and I will start the configuration on, I will do all the configuration from the first node. So I have executed this monitoring command on the second node and I am running the command from the first node. Okay, so what I'm doing over here, CRM resource stop. Okay, CRM, I'm stopping. So before starting the configuration, you can see that we already have a resource configured by the name StoneIt SBD. So what I'm doing over here, before starting the configuration, I'm removing that resource also. We will be removing that resource and we'll recreate the resource again in this part over here. So CRM resource stop. The first thing you can see that it is running, it is started. So first thing I need to stop the resource. So here I'm on the first node, I'm executing the command to stop the resource. Now you can see this resource has stopped. After issuing the command for the stop, this command, CRM resource stop StoneIt SBD, this command has stopped now. After this command has stopped, now what I'm going to do, I'm going to delete the resource. I am deleting the resource. See, the resource still exists. The resource has stopped, but the entry still exists. From the second command, I'm deleting the resource. Now, can you see no resources? It is showing no resources. All the resources have been deleted. So I have deleted the SBD resource, existing SBD resource. Okay, so now what I'm going to do, now you're going to put the cluster in the maintenance mode. Before we can start the resources, let us put the cluster in maintenance mode. So this is the command to put the cluster in maintenance mode. What happens in the, can you see over here? The resource management is disabled. The cluster will not attempt to start, stop, or recover services. So normally what happens when the first time you are configuring the cluster, most of the cluster is not stable. Some services start, some services fail over, and there's a lot of activities in the cluster. So just to not create any kind of chaos, you just put the cluster in a maintenance mode. So when you are adding any resources, new resources, everything fails or gives issue, the cluster will not interfere or try to start and stop the resources. Okay, so here we have put the cluster in a maintenance mode. Now, second, what you are doing, you are configuring some properties, bootstrap properties. The bootstrap properties of how to start up the cluster and some resources. So these are the value. CRM configure RSC default. This is the stickiness and the threshold value which I'm configuring. If you see the default value, if you want to see the default value, you can run this command. So here you can see the stickiness value. Can you see these two line over here? Resource stickiness is 1 and the migration threshold is 3. So we are changing this 1 to 1000 and 3 to 5000. You can run this command over here. Okay, both of them completed successfully. You will not see the output over here. You will not see any changes for this command here. If you want to see the changes, you have to again run the CRM configure show. So now can you see? You can see the value 1000 over here for stickiness, and for the threshold it is 5000. It has changed from the earlier value. Second comes recreating the StoneIt device. So there was an existing resource existed. We deleted that resource. Now we are going to create the resource. So normally what I'm going to do, I'm creating a file, and inside the file I'm giving the command for creating the resource. Okay, I'm not giving direct command to create the resource. The reason is that in case if I make a mistake, then you cannot edit the cluster. Okay, but in case if you have created a file, you can again go inside the file, you can make the changes, and again you can run the same command, load update. The changes will be integrated into the cluster. So this is the reason I'm not creating the resources directly from the command, but I'm creating a file. I'm saving the command in that file, and then after that I will call that file with this command CRM configure load update. So here I'm opening the file for StoneIt. So here I'm creating a file. Error detected while processing this command. Okay, new. I think there's some problem. Let me again run this command. I'm not sure why this happened. Let me again open it. BI command. Let me check on the other node. Repeat. Unknown function create detect file system. Press enter. Okay. This is a new thing. Surprisingly, it didn't occur anytime before. So let me just go and then TMP ls/TMP. Okay. df minus h. The slash command available 17 GB. Touch /TMP. Now let me run this command. Okay. This electronic process buffer read for selecting save this audio and save this file. Okay. Get /TMP storage. Okay, no issue with it, so we can just proceed. We just ignore that error message. CRM load configure. Now I created a file with the content of that command to create the StoneIt device. Again, here you don't see any resources right now. Let me run this command to configure load update. When I call this command, you can see the changes over. Can you see it has created a new device over here? It is stopped. It is not started. Why? Because the cluster is in maintenance mode. It will not start. It will not stop. So we just gave the command to create the resource, and it has created the resource. We just gave the command to create the resource. It has created a resource. It has not started the resource. Okay, so here we have done creating the StoneNet resource, then create the HANA topology. So here is the topology you're creating. So when you are creating a resource for your replication, which is called as your topology. So here you are creating a topology. You're saying that this is my master server and this is my slave server. So this is the normal, which is called as a topology. So again, create a file. I'm creating this file, vi, enter, executing the command. Okay, save it. And again, call the command, the CRM configure load update. Now you don't see the topology resource over here. Once I run this command, you can see the topology resource being created. Can you see the clone this set over here? This is the topology resource. This resource actually monitors and manages your replication in the server, in the cluster. Create the HANA resources. Now this is a resource for your database. Here I'm creating this file and adding this for your database resources. Okay, and here I'm running CRM configure load update. Okay, now if you see over here, see, you can see here, this is the resource for your database. You can see the slave HDPRD, the slave HDPRD2 unmanaged. This is the resource for your database. Okay. Now coming over here, create the virtual IP. Now here we are creating the virtual IP resource. Okay, here we are creating the virtual IP and the load balancer resources and group. So you are creating two resources. This is for your virtual IP. You are giving the virtual IP as standard 5.1.11 and you are creating a resource for your load balancer. See, Azure LB. You are creating a resource for your Azure load balancer. And this is the port number. If you remember, we gave this port number at the time of creating the LB. Okay, and then we are creating a group underscore IP in which we'll place the IP and the load balancer resource. So here I'm opening this file. Okay, here I am going to save it. Okay, configure load balance. Okay, now I'm clicking it over here. Now you can see the changes over here. Can you see? It has created this group. It has created this group for group IP, and this is the resource for IP. Okay, and you can see the heartbeat over here, IP address. This is the resource for our IP address. And the second one, this is the resource for load balancer, LB. You can see the resource type over here, Azure LB. So all of them have been created. Okay, all have been created, but nothing has been started now. And there are some constraints also. These are some limitations, some order, in which order you need to start the resources and which order it should be shut down. So these are called as constraints. So you are going to create some rule for the constraints. These are the rules for the constraints. Here I created the constraints and now configure load. There will be no changes here on the system here if you see any changes over here. Nothing there, you can not do because constraints don't reflect here. Okay, this is done. Now remove the cluster from maintenance mode. Now as soon as you remove the cluster from maintenance mode, you will see that it starts like you see many activities taking place in the cluster. See, right now it is just simple lying idle, no changes, nothing. But once you remove the cluster from the maintenance mode, it will start it will just try to start bringing up all the resources. Here I'm running the command to take out the cluster from the maintenance mode, and you can see all the activities. Can you see starting, and they started? You will see some errors also here. These errors you can safely ignore for the time being, because at the time of starting the resource clusters, at one time it sometimes gives an error, a failed resource action. It gives some fails messages also. So for the time being, just let the cluster do whatever it is doing. Just wait for the cluster to settle down. So now if you see over here, you can see for this IP resource, you can see that it has started the IP address, it has started the cluster resource. And you can see the slaves, both of the nodes have become the slave. And you can also see the clone set. You can see that both the nodes are member of the topology. This is okay. This is the proper value. This is the proper status. This status is not proper. One of the database should be a master and the other database should be slave. But this is the reason with this failed message is not taking any further action. So next, what you need to do, you need to clean up the HANA resources. Once you clean the HANA resources, it will again try to bring up the database. So let me run this command over here in the first node, and you can monitor from the second. See, again, it is trying to promote the PRD2 database. Again, it is trying to do something. You can see it is saying that the HGPRD1 is stopped. It is promoting the PR. It is doing some action. It is taking some action. Let the cluster complete doing whatever it is doing. Okay, one more thing that I wanted to show you is the IP resource. I told you can see the IPs from here. So now if you go on the first, okay, check in the cluster, where is the IP? If you see over here, you can see where it is started. It is started on the PRD2. The IP is started on the PRD2. Now, if you give this command IPA command on the node 1, you can only see the local IP address. Can you see 10.5.1.5? You will not see the 10.5.1.11 IP address on the first node. Why? Because it is started on the second node. If you come over here, if you give the IPA command, you will see the second. Can you see? Here is the local static IP address 10.5.1, and here you can see the virtual IP address 10.5.1.11. If you compare with the first one, see here there is only one static IP address. Here you can see the virtual IP address also. Okay, now can you see the masters is HDB PRD2 and the slave is HDB PRD1. Okay, it means the PRD2 is your primary database and the PRD1 is your secondary database. If you want to confirm, you can go here and you can check SU minus H4P. Okay, you can check the status of your application. SR state. So can you see over here? No, this is down actually. It is not up. Your database, this is your secondary database, but the data, sorry, this is your secondary system, but the database is not up. And if I check on the first node, H4 SR state. So can you see your secondary node is your primary, sorry, the database is started on the secondary database, this second node, and it is in the primary state. The first one, on the first one, the database is not started. On the first system, the database is not started. Okay, so now what you need to do, you need to start the database. Okay, one more thing, what we have taken here, we have set the configuration for automated start register is equal to true. Okay, so right now this database on the first node is not started. So what you can do, you can go and you can manually start the database. Okay, sorry, I made a mistake. I think it's still in the primary phase. I needed to register it with the secondary. This was a mistake. Okay, I think this was a mistake. The database is, sorry, yes. Can you see the database is online and it has changed the state over here. It has become the secondary system. It is in the log replay mode. This is the Mumbai side, the node 1, and you can see all details. The Delhi is the primary side and Mumbai is the secondary side. Okay, and also you can monitor your system with this command. You can monitor your with on the primary node, that is on the secondary node. You can execute this command, the HDB settings command. Okay, this command. So can you see the system over here? So everything, there's an active state. This is your primary. The PRD2 is your primary database, primary node, and the PRD1 is the secondary. Your database is in the active state. Every service is in the sync mode and it is inactive. So your everything is functioning properly. Yes, is it clear with everyone? And you can run this command over here, SAP. Okay, you need to run with the root user SAP monitor. So here you can see the overall status is green. The system replication green, the cluster green, SAP HANA SR green. Okay, syslog green. So there is no error in your cluster configuration with your HANA system replication. Also, you can check for SAP HANA SR show attribute. So here is the attributed. So here the node 1 is demoted because why? Because it is your secondary system. The node 2 is promoted because this is your primary system. This is the log replay mode. Your database is both the database are online. Okay, and this is your host IP host name. This is the site name. This is the score, and here you can see this is SOK. SOK means sync OK. Your secondary database. This is a secondary system. It is in the SOK. SOK means a sync OK state, and this secondary, this primary system is in the prim state, primary state. Yes, are we clear till now? Any doubts, any queries? Okay, so now let us do some testing for your cluster. Reference HA cluster testing. This is a separate text files over here. So we have many scenarios over here. I have up to like you can say 7, 8, 9 scenarios over here where you can see how the cluster you can monitor you can test the cluster. Okay, so first is your test one, stop primary database on node 1. What happens? So here it is a procedure test. So you have to give the command zero minus R. It is already running on the second node. This one is already running on the second node. Watch SAP HANA at this one. You need to run it on any of the nodes. So again, I'm running on the second node. Okay, so it is also running in the watch mode. This command is also running. Okay, now what do you need to do on the first node? This is the primary. One means primary, not on the first node. One means on the primary node. You have to run this command on the primary HDB stop. I have to run this command on the primary. Stop the primary HANA database gracefully as a side area. So let me again open another duplicate session for this one. SU minus H4P and let me stop the database. So expected, see it is giving you what is expected. The cluster detects the stop primary HANA database on node 1 and marks the resource as failed. The cluster promotes the secondary HANA database on node 2 to take over as primary. The cluster migrates the IP address to the new primary on node 2. After some time, the cluster shows the sync state of the secondary primary as fail. These are the expected values. So let me run this command HDB stop. So once you run this command HDB stop, after some time, it will detect that this node, the master node, the database has stopped on this node. It will detect it. Still going down. Okay, the database is stopped now. Let me check the system now. Let me see how. So it takes some time. It is not instant because there is a timeout or there is a timing threshold for monitoring the data system, for monitoring the services. It might be 30 seconds, 20 seconds, 15 seconds, maybe 60 seconds also. So after that interval, it will go and it will monitor the service. So till now that it has not like identified whether the database is down or not on the primary. And if you see over here, your virtual IP is running on node 2. Okay, the virtual IP is now running on node 2. When it will identify the database, see here it is identified. Can you see it has identified as a failed? The HTTP2 has failed, and it has started the IP address resources on the PRD1. It has moved the virtual IP. Now, if you see here over here, if you see the virtual IP address IPA, see you will not see the virtual IP address here in the node 2. And similarly, if you open it over here in the node 1, see you can see the virtual IP now in the node 1. Earlier it was there in the node 2, now it has again came back to node 1. Here it is. Now it is promoting the HTTP. Now it is taking over. Promoting means it is the HPRD1 is taking over the role of primary as a primary database. Okay, so cluster detects the stop primary handed node and mark the resource failed. So here you can see it will mark it as failed. So here it is not given. See here it is marked as failed. Failed resources PRD2. It is showing as failed. The cluster promote the secondary HANA. So now it is promoting the secondary, that is the PRD1 as a primary now. The cluster migrate the IP address to the new primary. So here you can see earlier it was on PRD2, now it is on PRD1. And after some time, the cluster shows the sync state. So here, if you see here the sync state, you can see the sync state has failed. After some time, the cluster shows the sync state of the stop primary on node 1 as failed. Procedure recovery, manually register the primary old node on the this is. Now it is saying you to manually register, but in our case we don't require to manually register. Why? Because we have set the setting automated register to true, so no need for manually registering. If you see the configuration, see here, if you see the configuration, we have made it automated register is equal to true. So no need for manual registration. It will be registered automatically. If you want to see, you can go on the node 2 here and you can run the SR underscore state. Okay, you can see it is the database is not started on this node yet. Okay, it is not started. Why? Because the resource is still showing as failed. The resource is showing as failed, so it will not take any action till you identify the issue and you have to instruct the cluster that this issue has been corrected, rectified. Okay, so how? Because I know that I had manually shut down the database. So now if you want to correct this issue, I can directly go and you can run this command to CRM resource cleanup. You can run this cleanup and it will start recovering. It will clear the failed flag and it will start recovering it. Now let me run it. Okay, I've run this command and I will see changes over here. See, it has started taking action. Now it is taking for the slave as a HTTP PRD2. Now if you see over here, it will start bringing it up. It will start HTTP status info. See, now it is bringing up the database. See, it has started bringing up the database. Before the database was down. If you see over here, the database was down, online is equal to false. But now after clearing the default of the cluster has started bringing up the database on PRD2. So here you can see it has started bringing up the database on PRD2. Now if you check the SR state, now, earlier what it gave the database is down and it gave the SR state as primary. But now if you run the SR state, now you can see the database is online and the SR state is in sync. Yes, am I clear till now? Yes, everyone. Okay, so no problem. So we don't have any time right now to test all the 9 procedures. So I'll be sharing this text file with you. So after your configuration, you can go through all this 9 tests and you can check for yourself, test for yourself. Okay, so now we'll be stopping the system now. So to stop the system in the cluster, what you need to do is that I need to shut down the secondary node first. So this is the 2 is the secondary node. I'm going to shut down the secondary node first. I can run this command on the primary. The crm underscore mon minus r. I will run it on primary and I will shut down the secondary node. You can see power off. I am shutting down the secondary node. So if you see over here, after some time, the secondary node will go down. Okay, here can you see online? Only the PRD1 is online. PRD2 has gone offline. Okay, now after PRD2 has gone offline, now you can run the power off on the first node also. After like we on a difference of 2 or 3 minutes or maybe 5 minutes, you can run the power off on the first node. That is also down now. Okay, so this is, I think we're done with it. Now after running the stopping the system, I can shut it down or shut them down from my portal also. So it is still running, it is updating. Okay, so any doubts, any queries? Okay, then we will end this session here and I'll share the meeting recording and the sheets with you. Okay, goodbye everyone.
Goodbye.